Okay, yesterday we did translating systems of equations, and we're looking at application problems. Today we're going to do a little bit of the same thing, but these are going to be slightly easier, just a little different type of problem. So I'm just going to give you a couple, 4 or 5 examples on this, go through it quickly, and then call it a day. All right, so this is the second part of our translating systems of equations. Basically, we're going to take this scenario right here, translate it into a system of equations, and then solve it. Okay, it says one number is 6 less than 5 times the number. Okay, these are, in my opinion, these are easier because it's telling you in a sentence form what your mathematical sentence should be. So one number, if it says one number, that is a key word to tell you that you don't know what that number is. So one number is something like x. Again, the word is equals 6 less than. When you see less than, this little phrase, or more than, then you're going to have to put this at the back of your sentence. And I'll explain that here in a second. Now, if you see the word is less than, then you're dealing with an inequality. And we're going to be talking about inequalities in the next week or so. So one number, okay, so here's my systems, and I'm using the variables x and y. So one number, x, is 6 less than. That means it's got to go back, and less than means minus. Okay? So it goes at the back of this number sentence. Something's got to come in front of that less than. Is less than what? It's less than 5 times another number. Another number means a different variable. So 5 times y. So one number is one number is 6 less than 5 times another number. That's how that works out. Okay? Their difference, that means we're subtracting. Their difference is, that means equals 22. So their difference, meaning x minus y, is 22. So their difference, the two numbers' difference, is 22. Find the numbers. Okay? So now we have our system of equations set up. 2 or more equations creates a system of equations. In this case, our system is set up for what method? Easily to tell. Since x are already something, we're going to probably use the substitution method. So let's go ahead and solve this quickly. So I'm going to take this value here, and I'm going to substitute it in for that x. So totally replacing the x with 5y minus 6 minus y equals 22. Don't forget to bring this minus y back on there. Now I only have one variable, so I can go ahead and solve for that variable. That variable is y. Combine my like terms right here, 5y and negative y. So 5y minus y is 4y minus 6 equals 22. Now quickly solve, or easily solve for y. Add 6 to both sides. This eliminates. This leaves me with 4y equals 22 plus 6 is 28. Divide both sides by 4. Y equals 7. Okay? You can go ahead and box this answer. This is not going to be a coordinate form because we're not talking about just a generic system. If I was given a system like we were given on Tuesday where it's automatically given to you, then you write it in ordered pair form. Because I'm not necessarily looking for an ordered pair, I just chose x and y. I could have used any variables I wanted, but I just chose x and y. So you can just box each of your answers. Okay, so y is 7. Now I go back to one of my original equations to solve for x. Well, since this one's already really solved for x, all I got to do is plug in y and simplify. So I'm going to go to that one. X equals 5 times 7 now because y is 7. I don't have to write the y. I put 7 there. Minus 6. So x is equal to 35 minus 6. X is equal to 29. So then I can go back in and check. Is 29 minus 7 22? It is. Is 29 5 times 7 minus 6? It absolutely is. Okay, make sure you have that down. Excuse me. Let's look at another example. It says the perimeter of a rectangular garden is 46 feet. Okay, again, when I see this word rectangular, I'm going to go ahead and draw my picture over to the side. It's just a little bit easier for me to visualize what I'm looking at. So the perimeter of a rectangular garden is 46 feet. So P equals 46. Perimeter is usually identified by the variable P. Now remember, when we're dealing with the perimeter of a rectangle, we have the formula P equals 2L plus 2W. Should have learned that last night. Okay, and that's just automatic. That's just something that is known. Okay. So the length of the garden, length, that would be this side here. Length is, so the length I'm going to use as the variable L. So L equals length. When excuse me, when you're dealing with variables that need to represent something like length and width, make sure you identify the L equals length. Don't just put two variables up there. You need to put L equals length. Up here, it didn't matter because up here I was dealing with numbers, so it really didn't matter. But down here I need to put L equals length. So L, the length of the garden is, again, that's equals. So L equals 5 less than. Again, we see that word less than. So you got to put that at the back. So, excuse me. Put minus 5 back here. It's got to be less than something in front of it, okay? 3 times the width, okay? We know what 3 times is. That's pretty easy. And the width, I'm going to use W. So my variables are L for length and W for width. So 3 times W. So length is 5 less than 3 times the width. Excuse me. Okay, so then this is going to be the width by itself. So find the length of the garden. Okay, so right here we have one equation for our system. We need to have 2 or more equations. So here we have one. L equals 3W minus 5. And then on the next one, we have perimeter. We can fill that in. That 46 can go right here where this P is, and you have 46 equals 2L plus 2W. Okay, and then we go ahead and solve that. Again, this is set up for substitution because I know what L is. So I'm going to put 46 equals 2 times 3W minus 5 plus 2W. In order to solve this, I got to bring down that 46, distribute the 2. I get 6W, distribute the 2 here, minus 10 plus 2W. Now you might be asking yourself, why are we solving for W when we need to know the length? The length is the only thing it's asking for. Well, in order to find the length, we got to find the W first, okay? In this particular situation, you could have probably manipulated the equations to find the length, but this is probably the quickest and easiest way. So now we're going to combine like terms. We got 46 equals 6 plus 2 is 8W minus 10. Okay, I'm going to move this up here. 46 equals 8W minus 10. Add 10 to both sides. Now you have 56 equals 8W. Divide both sides by 8. And now you have 7 equals W. So you know the width is 7. So now I got to go back in and plug that 7 in for this length equation that we created earlier. So I'm going to go back over here and put L equals 3 times 7 minus 5. So L equals 21 minus 5. L equals 16. And that'd be 16 feet. And there's our solution. Okay, and then you can go back in and check, is the length 5 less than 3 times the width? It is. Okay, if I plug in 16 and 7 into this equation, does it equal 46? And you'll find that it does. Okay.